Hello everyone, today we're kicking off Understanding VXLAN EVPN video series. This is a full-on VXLAN setup using GNS3. Most people would struggle to run a lab like this because it's resource heavy, but I'm running this entire 7 device fabric on an Ubuntu GNS3 server with 96 gigs of memory. So let's look at what we have here. We're not just doing a basic lab. As you can see in the topology, we have 3 spines, 4 leaves. The leaves are called VTEPs. VTEP stands for VXLAN tunnel endpoints. The spines are CSR 1000Vs running version 16.6, and they're acting as our BGP route reflectors. The VTEPs, those are 9Ks running NX OS 10.5.1, which is the latest OS at the time of this recording. The reason I created this video series is because I went through countless of videos on VXLAN and I just needed more. So if you're like me and you need to create a lab and go through each relevant command and have an explanation for each one, that's what I do here. What is the command? Why do we need it? And what does it do? So I created the lab so you won't have to, and we'll go through each one of those. So the goal here is we're going to extend layer 2 across the layer 3 fabric. For example, we have Ubuntu Desktop 1 here on VTEP 1. And it's going to be able to talk to VTEP 4 Desktop 12. So it's going to be seen as if it was one big switch, but let's say each one of these VTEPs would be a separate building. But because of VXLAN, they won't know that. Again, they'll see it as if they were on the same switch. We'll be talking about the underlay and the overlay. So think of the underlay as the physical road and the overlay as the virtual delivery route. Let me go over a little bit of the underlay and the overlay. So the underlay, the physical road. The underlay is the actual physical infrastructure. Its only job is to provide IP reachability between your leaves and your spine switches. What does it do? Well, it ensures that VTEP 1, which is going to be a loopback of 0, would be 11.11.11.11, can ping VTEP 4, loopback 0, 44.44.44.44 across the fabric. The protocol for the underlay we're going to be using is OSPF. OSPF learns the path through the spines so the leaf switches know how to reach one another. Another important point is the MTU. Because VXLAN adds an envelope around each packet, the underlay must have a larger MTU. So the interfaces by default are going to be having an MTU of 1500. You can do a show interface and you'll see that. But because we're going to be using VXLAN, that adds an extra 50 bytes to it. Now, if you were to do under an interface MTU question mark, you'll see that the 9Ks will allow 9216. So I just went ahead and on all the interfaces, I added 9216 to them. Let's talk about the overlay, the virtual delivery route. This is your virtual delivery route. The overlay is the virtual network that rides on top of the underlay. It is completely unaware of the physical wiring. It only cares about the endpoints. What does it do? It creates a layer 2 tunnel, the VXLAN tunnel, across the layer 3 underlay. What protocol are we going to be using for overlay? Well, in this config, we're going to be using BGP EVPN. BGP acts as the brains, telling VTEP 1 exactly where Ubuntu Desktop 8 is without having to flood the whole network. The segments. This is where your VNIs live, and the VNI would be VXLAN network identifiers. For example, VNI 10,010 allows Ubuntu Desktop 1 and Ubuntu Desktop 2 to communicate as if they were on the same VLAN, even though the underlay is routing them across different spines. Now the VNI can be any number, but it's going to be associated to a VLAN. Now in a traditional network, you're going to have to be on the same VLAN, right, to be able to communicate when there's no router, right? So if it needs to go up to the router, it strips the VLAN. But in this case, it's what really matters here is the VNI. So if I say on VTEP 1, I'm going to be using VLAN 10, and I'm going to associate VLAN 10 to VNI 10,010, and I can come to VTEP 4 and I can say, hey, VLAN 10 here is going to be VNI 10,010. Now this is the kind of cool and tricky part, is you don't have to put VLAN 10 here, right? You can set this device to say VLAN, let's say 1000 or whatnot, 20, 30, whatever, it doesn't matter. As long as that VLAN is associated to the same VNI, which is 10,010, these two guys will know that they're on basically the same segment. So again, think of the underlay as a physical foundation of our data center. It's the OSPF plumbing, so to speak, and it's what makes sure our switches can see each other. The overlay is where the magic happens. It's a virtual network that uses BGP EVPN to stretch our subnets across the entire fabric, letting our hosts talk to each other no matter where they're plugged in. So you may ask, why does this matter? Well, traditional spanning tree is dead in the data center. If you want to work in modern cloud environments or large enterprise campus networks, you'll need to understand how VNIs and VRS work together to provide multi-tenancy. Now I've set up tenant A with its own VNI of 50,000 to show you exactly how that's done. And again, we'll go through each and every one of these VXLAN commands, the whys, why are they needed, and what they do. In the next video, we'll go over a little bit more about what VXLAN is and what it does, and we'll look at my GNS3 topology and start configuring spine 1 with the underlay OSPF. I'll see you in the next video.